Welcome to Class 17. In the previous class, we looked at high-rise construction utilizing a steel frame and creating a commercial office tower. Now we're going to look at a different technique. This is a concrete frame building, and the finished product will be a residential tower. This is the site at the very earliest stage of construction. On the left side, you can see the first tower that was constructed in this redevelopment area. This is in Queens, New York, a beautiful site right on the East River. That first tower was a success, and now several additional buildings will be constructed. We will be examining the building in the foreground. The piles had already been driven before I began filming this construction, so I'm going to switch to a different site which uses a similar pile foundation so that you can get a look at what that process is like. I wanted you to have a look at pile driving equipment and just watch the behavior of this pile. It's quite unusual. It passes through a very thick layer of very soft material. You would call that a push. The hammer is not even working. Just the weight of the hammer itself is pushing the pile through this soft material. A layer of soft material like that can be a real problem in terms of how will these roadways begin to settle over time. Once you add load to this very compressible layer, you can expect some long-term settlement. Here the pile is being driven not to refusal. Refusal would mean driving it to rock where it simply won't go any further. But this pile seems to be advancing, and some predetermination has been made as to when it reaches satisfactory resistance. So the inspector who is tracking the progress is looking for this predetermined amount, and it might be 6 or 8 or 10 blows to advance the pile an inch. This has been worked out in advance, and he's just there to verify that the pile is reaching this predetermined amount. Now you can see it's getting very, very close to the ground, and he is counting these last few blows. In another minute, the rig really will not be able to advance it any further. So we're all waiting to see if this is a good pile or not. The inspector signals it's okay, and you can only wonder if he was under the pressure of calling it good before the pile driving would have to stop in any event. And then you would have to splice another section onto the pile and continue driving. So this is a pile load test. You construct a platform of heavily weighted material above the driven pile, and you introduce a hydraulic jack between the top of the pile and the dead load that you've created, and you jack against the pile and measure the deflection or the movement of the pile over time. You plot out all of the results and see from the results whether or not it's behaving the way you want it to behave and is developing the capacity that you're looking for your structure. If it is, then the pile test passes, and the criteria that you used for deriving how many blows per inch
will be deemed satisfactory. You will have tested it in place and determined that that size hammer driven with that many blows per inch produces the capacity that you're looking for. If it falls short, you may have to increase the number of blows per inch and try again until you develop a pile which has the capacity that you want. In this case, the platform of weight looks like it's a series of pig iron blocks, but it can be concrete blocks, it can be even precast concrete barriers, whatever material you have available. Under certain circumstances, you can drive a pile on either side of the test pile and actually jack against the two adjoining piles. Of course, the adjoining piles have to have a tremendous resistance against uplift because you don't want to pull them out of the ground before you've reached the capacity for your test. So this is how you test the capacity of a driven pile right on your site and determine that you're using or verify that you're using the correct driving criteria.